So, have you ever really stopped to think about what's going on inside an AI's head? I mean, beyond all the sci-fi stuff. Today, we're going to pull back that curtain and look at how a machine actually learns to think. Let's dive right in.
Really, it all boils down to this one question. And honestly, the best way to wrap your head around AI is to picture it as a student. Yeah, a student. It starts off knowing absolutely nothing, a total blank slate, but it has this incredible ability to learn. So where does that first lesson even start?
All right, class is in session. The first thing our brand new AI student has to figure out is, what's its job? What's it even supposed to be doing? And you know what? At its core, it's probably a lot simpler than you think.
Okay, so the big idea here is something called a function. Just think of it like a rule or maybe a recipe. The AI's entire goal, its whole reason for being, is to find the perfect rule that connects the question to its answer. So you give it an input, say all the details about a house, and it has to learn the function to spit out the right output, like the house's price. That's it. At the end of the day, it's really just a prediction machine.
And just like any student, our AI has to start with the basics, right? It's got two main subjects in its AI 101 class. First up is regression. This is all about predicting a number that can be anything along a scale. Think a house price or tomorrow's stock price. The second subject is classification, and that's about making a clear choice. Is this email junk or not? Is that a picture of a cat or is it a dog? These two simple skills, they're the building blocks for pretty much everything else AI does. Okay, so our AI student knows its assignment, but how does it actually get good at it? How does it go from an F to an A+? Well, it hits the books, hard. It learns by studying thousands, sometimes millions, even billions of examples. And this process is kind of like cramming for a test. First, the AI is handed a giant stack of digital flashcards. We call this the training data. Think a picture of a cat with the label cat. Easy enough. Then it has to make a guess. Based on what little it knows, it might say, dog? Now, step 3 is where it gets interesting. It gets graded. The system tells it exactly how wrong it was. And finally, and this is the actual learning part, it tweaks its internal thinking just a tiny bit so it's less wrong the next time. Now, imagine doing that millions of times. It gets a little bit smarter with every single mistake.
So where is all this thinking and studying actually happening? Well, it's all going down inside something called a neural network, which is basically a computer system designed to work a bit like, well, like our own brains.
This network is built with layers of what we call virtual neurons. First, you've got the input layer. Think of it as the AI senses, its eyes and ears, just taking in all the raw information. Then comes the really cool part, the hidden layers. This is where the heavy lifting happens. Each layer looks for more and more complex patterns. So the first layer might see simple lines and colors. The next layer puts those together to see shapes, like an ear or a whisker. And the layer after that puts those together until, boom, it recognizes a whole cat. And then finally, you have the output layer, which just gives you the final answer. Cat. And this is the absolute key to understanding all of this. For an AI, learning isn't some fuzzy, abstract idea. No, it's pure math. The AI is literally just adjusting the strength of the connections between all those little neurons we talked about. A stronger connection basically means, hey, this is important. A weaker one means, not so much. So the whole process of it getting smarter is really just the AI meticulously turning millions of tiny digital knobs, trying to find the perfect settings. So after acing AI 101, our student is ready for the big leagues, grad school. And this is where we get to the kind of AI that's everywhere today, the super powerful models like ChatGPT. We call them large language models.
And the name pretty much says it all, right? They're large because they've been trained on a truly insane amount of text. I mean, we're talking about a giant chunk of the entire internet. It's like they've read every book in the world's biggest library, and then some. And that huge wealth of examples is exactly why they can write things that sound so incredibly human. In a sense, there's almost nothing they haven't seen before.
But listen, it's not just about having a ton of data. These advanced models, these LLMs, they have a special trick up their sleeve. It's a superpower called self-attention. And this is the secret sauce. It's what lets the model really understand context. It can look at a whole sentence and figure out which words are the most important for understanding the real meaning. Yeah, this quote really nails it. The model is constantly tracking how all the words in a sentence relate to each other, building this complex web of meaning. So, for example, if you give it the sentence, "The bee landed on the flower because it wanted nectar," the self-attention part is smart enough to know that it refers to the bee, not the flower. I mean, that seems obvious to us, but for a machine, that's a huge leap in understanding context. It was a total game changer. So here we are. Our student has graduated summa cum laude. It's an expert, it can write poetry, it can code software, it can answer unbelievably complex questions. But all of this, it leads us to the biggest, and maybe the most important, question of all. After all of that training, after building this incredibly complex digital brain, does it actually understand any of it? Is it really thinking? Does it comprehend the meaning behind the words it strings together so flawlessly? And the answer, at least for now, based on everything we currently know, is no. What's really going on under the hood is something much more, well, mathematical. An AI is the ultimate pattern-matching machine. It doesn't feel sadness. It just knows, from analyzing billions of sentences, that words like tears and heartbreak have a very high statistical chance of appearing near the word sadness.
And that, right there, is the fundamental difference. Our human intelligence is a messy, beautiful mix of consciousness, feelings, memories, and actual life experiences. AI intelligence? It's all about statistical probability. When it generates a sentence, it's just playing a game of what's the most likely next word, over and over again. It's an amazing, mind-blowing simulation of understanding, but it's not the real deal. Which leads us with one last and really critical thought. We have built this incredible tool, a master predictor that can see patterns we could never dream of seeing, but it has no idea what it's actually doing. So as we start weaving these AIs deeper and deeper into our lives, into our hospitals, our courtrooms, everywhere, the one question we all have to keep asking ourselves is this. If AI is a master of prediction, but not of understanding, what decisions should we really be trusting it to make?